Today I'll be talking through what's new in Simcenter Femap 2022.1 and really just going over the exciting updates that they've rolled out for this release. Today we'll talk through the background of Structures.aero and then some of the updates that are rolling out with this release. And some of those include, just in broad terms, the Kinematic Joints features that are being added. Those are new. The flexible sliders that are being capability that is being added, those are also new. And then we'll go over some meshing updates, performance improvements, changes to the user interface, and some of the solver support changes that they've included, as well as the API updates that they've added to keep up with the general functionality that's added. So a little bit about us first. We are a team of 19 engineers here at Structures.aero, comprising of a wide range of degrees, including aerospace and mechanical engineering, as well as engineering, science, and mechanics. Basically, we are all experts at Femap and use Femap and Nastran every day. Some of our recent projects here at Structures.aero are really distributed amongst a broad variety of companies, but we really work with companies in the space, aircraft, UAV, and then kind of like the other industry. Space, I think some of our current and past work includes working with Blue Origin on New Glenn, Sierra Nevada on the Dream Chaser. Actually, I think my screen is paused. Here we go. Some of our recent projects obviously include Blue Origin with New Glenn, Sierra Nevada with the Dream Chaser, the Piper M600, Wing for the aircraft section, the Airbus Vahana VTOL. Some of the larger projects include TSE White Knight 2 and Boom Supersonic XB1, which I believe they're flight testing right now. And then we also do a lot of work for UAVs, including AAI's Aerosond. And then we've also done some work just in general for some dredges, ground support systems for aircraft, but a wide range of structures that our company covers. So another portion of the business here at Structures.aero is Sda Software. And Sda Software is a Siemens Value-Added Reseller. And basically what this means is we use the software that we also sell. And we sell Femap, obviously, coupled with NX Nastran, SimCenter 3D, also coupled with NX Nastran, and then a lot of other software, including Flow EFD, Star CCM, Fibersim. Those are some big ones, and NX CAD 2, as well as Solid Edge Heats and Amisim. We also offer training, and we are actually offering a training class soon. It's going to be on the Introduction to Femap with NX Nastran, and that's on February 7th through 11th. So if you are interested in that class, we'll have some contact info at the end of this webinar, or you can just contact any of us directly. And then obviously we also offer advanced Femap training and also Fibersim training. In addition to supporting all this this wide variety of software, selling the software, we also support the use of that software. And that means that we're in constant contact with the people who buy the software from us, and then we're also in constant contact with Siemens, the writers of the software. And that means there's open communication lines for fixing bugs or like suggesting new features. And that's something that I really appreciate about that relationship is, you know, if you find something that needs to be fixed or added, that can be incorporated very quickly. All right, so let's get into the updates for Femap 2022.1, and we'll start off with the Kinematic Joints. So the addition of Kinematic Joints is essentially a system for analyzing mechanisms, basically. And basically it allows you to connect parts together with different types of joints. there are a couple different types of joints, and we'll cover those. But basically, you'll have 6 relative degrees of freedom and kinematic constraints to constrain your bodies. And Femap will basically, after you set up these kinematic joints, which are kind of conceptual, Femap will translate them and export these joints into actual elements when you actually go to solve your model. So here's kind of one example on the right of a U-joint, and it kind of gives you an idea of the connections that you can set up with this type of kinematic joint. They're specifically for solution 402, but they're adding support for ANSYS and Abacus. But basically, they allow you to define revolute joints, spherical, fixed, universal, and constant velocity joints, as well as slider joints like inline, cylindrical, slider, universal, that type of thing. But one important thing is this is, or maybe will be in the very near future, a solver neutral interface. So when you define this joint, it really shows up as like more of like a symbol in Femap, and then when you export it, it basically expands the joint and writes the actual elements that define that joint. And there are 2 approaches for defining these joints. It's either a kinematic joint or a joint connection. And you can manually define the kinematic joints by defining the nodes that you're connecting together, or whether you're going to use something more in-depth like rigid type elements for attachment to like a motion body or something. If you're defining a joint connection, this is a little bit more in-depth, but you can see you have a selection box for the reference and the motion attachment, and then these follow points, curves, surfaces, elements, nodes to ground. There's really a wide variety of things that you can select for that side of the joint. So it's really helpful if your geometry is attached to a solid, because you can just select the surface or surfaces that you're interested in, that type of thing. And these are super helpful because basically it does all the work for you in terms of setting up something like this. It'd be really hard to set up like a rotating coordinate system that kind of has to spin about a different axis. It's just pretty much not possible unless you write your own thing to basically do this. So obviously I've covered some of the benefits, but again, one of the main benefits here is that it's a solver neutral approach. So basically the connection exists in Femap, but you don't see what it's doing until it actually exports. And if you re-import that input file, you can actually see what's happening. And in this case, it looks like this connection is a rigid with some sort of element in between and a rigid on the other side. And you can see it handles them differently for, or it will handle this differently for ANSYS and Abacus in the future. And here's one example of just these moving joints that allow you to simulate motion of like a mechanism. I personally don't do a whole lot of mechanism analysis, but I can see how this would be super useful for someone who was trying to define some sort of analysis like this. And so along with the kinematic joints, they also have driver loads, and there are a couple different loads, including force, torque, displacement, and rotation. All right, so moving on to flexible sliders. The addition of flexible sliders to Femap basically allows you to simulate the deformation of a track as you displace something along that track. And this could be useful in like a wide variety of applications, but I personally have not used these yet, but I think this could definitely be helpful for a wide variety of customers. So there are a lot of different options for the sliders as well. It seems very similar to the kinematic constraint or the kinematic joints. you can see you have spherical, cylindrical, prismatic, universal sliders, and then also force and displacement and censored load types. And there's also options for friction along those sliders. And you can see basically you can either select a node group or a node list for your entities to be displaced along that slider, and then either a group of beam elements, or you can select here in this dialog to get your beam elements to define that slider trajectory. And here's a quick example of some sort of, it looks like a car frame sliding along a track. Okay, so here's the part of the webinar that I've been wanting to dive into from the very beginning. This is my favorite part of the 2022.1 updates. And the update that I'm most excited about is this new hex dominant meshing capability. So previously within Femap, if you needed to solid mesh something that's really chunky and that wasn't great to be represented by a plate mesh, you'd have to slice it up and then sweep the mesh through those different sliced up sections. You'd have to get it into basically sweepable chunks and then make sure all those faces matched up so your mesh was connected through all those different solid chunks. And this process was super manual and basically prevented you from doing any type of quick hex meshing. Now, Femap has introduced new technology, actually I think from a CFD platform, Flow EFD, but it's able to give you a hex dominant mesh in a solid volume without having to slice it up. It's not actually slicing it up under the hood, I don't think. It's meshing using this Flow EFD technology. So it fills the volume with as many hex elements as possible, and then fills the remaining volume with wedge, pyramid, and tetrahedral elements. So here's the new dialog for setting up a hex dominant body. You can see you can give it a target element size. You can ask it to use curve sizing, that if you've already like sized some curves yourself. And then there's also the ability to select all geometry to force the mesh to conform to all geometry. It will auto-detect required geometry if that's what you choose. And then you can also add selected geometry, and if it thinks that some surface you don't need but you actually do. And then there's also some of that selection propagation information here. And then additionally, there's an option to remove mid-side nodes on all of the elements but the brick elements. Actually, no, remove all the elements on the brick elements, keeping the mid-side nodes on all the Tet elements. So I think I'm going to jump into Femap here to quickly demonstrate this. This is a just a bracket that I've quickly modeled up in NX, and this is 2022, by the way. The new command here for the Hex Mesh is located right here under Hex Mesh Bodies. And I'm not going to run through the mesh right now because I've actually generated it already. But here is this part that using their new hex dominant mesher. And you can see here that it is a mix of brick elements. Here are all my brick elements. And here's the Tet elements. And you can see they're really only located near areas of high curvature. And then here are the wedge and the pyramid elements. So it's not fully hex, right? It's a mix of both, but it's predominantly hex elements. And it actually gives you a good report on how much time it took to mesh and the mesh quality options once that mesher is done running. I did want to compare to the Tet Mesh version. Here's the Tet Mesh using the, I think a new feature for 2021 the mesh body command. This is without any like surface or curvature refinement, and it's basically that I mesh these two bodies with the same amount of resolution. And you can see that the nodes in this model are about 173,000, whereas in this model there are 87,000 nodes for the same amount of mesh resolution. And I think these are parabolic hex elements. So basically what this enables you to do now is previously, if you needed a solid mesh of something, unless you wanted to spend a lot of time on it, you had to basically Tet bomb it. But now you can kind of do the same thing with hex elements, also with a much lower node count, or you can increase the resolution for the same node count. One of the options that I did want to point out here is wrong command. If we go ahead and open this additional geometry by angle command will, I think it'll basically ask the mesh to conform to the geometry a little bit better. This is all described well in the Femap Help. But just that one command makes the mesh refine a little bit more in these fillets, and you can see you definitely do have some more Tet elements, but in the transition from Tet back to a more refined hex. But this more closely matches something that would come out of the Tet mesher if you had some sort of surface curvature refinement. Actually, yeah, something like this. So another benefit of this hex mesher is if you don't need the resolution of like a refined hex mesh, you can keep the surface refinements off, especially if you just need this like a chunky bracket or something meshed for stiffness in like a global model. That could be another option too. Instead of having to Tet bomb it and end up with like a huge number of nodes. So yeah, I'm super excited about this new capability within Femap. I downloaded this version pretty much right when I saw it was released and started messing around with the new hex dominant mesher. So again, here's just a comparison. You have 173,000 nodes versus 87,000 nodes for the same amount of mesh density. And then here's the same comparison with the curvature refinement on the Tet mesh, and then that proximity refinement, or what was it? The additional geometry by angle, 30-degree angle command. All right, so the next improvement is also in the realm of hex meshing, but it's an improvement to the legacy method. So basically, when you do have your solid sliced up, you can now, and it's mapped using a hex mapped mesh. You can now, like almost like with a plate, when you just click and refine, you can do that with this solid hex mesh now, and it'll propagate that refinement out to wherever you need it to be. But it's, when I first saw this, I thought it was for this like hex dominant mesher, but it's important to note that it's only for this mapped hex mesher. But still very useful, especially if you have something simple that's easy to slice up, where it may just take just as much time to do mapped hex versus the hex dominant mesher. All right, let's move on to some performance improvements. There were just a few performance improvements to this version. However, I think some of these are actually really important. So as always, they're always improving the performance graphics. They now support constraint equations and constraint equation labels, as well as regions. But the biggest thing for me is the 2 times improvement in expansion of geometry-based pressure loads to element faces, as well as improved performance when updating groups. And the biggest performance improvement by far is the 35x performance improvement for capturing animate multi-set frames. And this is not just for capturing images, it's also for just displaying it in the Femap window. And especially if you're trying to like rotate around big models where you're trying to animate like a mode or a flutter mode or something, we've seen huge improvements in how fast it takes to render. Because I think in the past we would have to load in the whole animation, and then maybe it even did that twice for some reason. And now it's super quick. It does it a lot faster, and it only has to load it in once. So when you spin it around, it doesn't have to load it all in again. The data's already there, and it just has to quickly redo the animation. So yeah, I know a lot of people are super happy with that update. Okay, moving on to some quick user interface updates. This is a really small one. If you ever have to preview your input or add some sort of flag or command to the input file, they've added a find command here. So that can be helpful if your bulk data file is like super long and you're looking for something that's not necessarily at the top. I know I've already used this. So another thing that they've added is you can switch between whether this is the standard, entity display. You can turn on curves, points, surfaces, elements, whatever, but they've also added the ability to turn on and off the labels of these entities. So I could see this being a little confusing at first, especially if you get stuck here and you don't realize you've clicked this button and you're stuck displaying labels. But as long as you remember that this exists, you can switch back into this, and then it can be helpful because you can selectively turn off labels for these different things right from the Femap GUI. All right, moving right along. For grouping and selection, they've added a few new selection methods which are very helpful. In terms of grouping, they've added grouping the nodes on points, curves, and surfaces of solids, and then same for the elements. And then they've also added similar options just in general when you're selecting different entities. These are the new things on points of solid, on curves of solid, and on surfaces of solid. And another thing that they've added in terms of handling groups is that now you can evaluate a group right from the model info tree. Previously, you had to go up into the tab group, operations, and then evaluate. So this is a lot easier, a lot more quick, especially if you do something like that all the time. This is kind of a big change. The Femap Help has been moved to an HTML version. So basically, if you hit F1, it now opens up your web browser and sends you to the online help. But you can also change this to a local help server if you need to. I haven't done this yet, but I may, just in case like the internet's slow, or you may just want to, it may be faster if it's local. But it's searchable and you can bookmark it with a browser. So yeah, there's pluses and minuses there. All right, going into the solver support. If you ever have to use Femap and SimCenter together, this is going to matter to you. Now you can choose whether you want Femap to output your results in a Femap OP2 or a SimCenter OP2. So if you were working in SimCenter 3D, but you wanted to import Femap results, I assume you would check this box globally in your Femap file preferences or locally in your individual analysis set output requests. This one will kind of set the default, and then this one will kind of override that default if you need to change it. Another thing they've brought over from SimCenter is the solution monitor. You can now kick this off from Femap. I think it's just it's an option in the executive and solution options, whether you want the usual solution monitor or this new SimCenter 3D Nastran solution monitor. as you can see, I think there may be a few more graphs you can access, or maybe they're just in a more like user-friendly fashion. And then obviously they've added solver support for flexible sliders. I think you do have to, if you are using these, you do have to go into the analysis set and activate it. But this is a manager for that. And then obviously the same thing for the kinematic joints. You have to go and check it in the analysis set to make sure that it's included. Kind of the same thing for monitor points if you've ever had to deal with that. There's also time-dependent temperature set definition capability here. So if you're running something like that in solution 4.1 or 4.2, you can create a referenced temperature set and feed it a bunch of different temperatures for different times. And they've also updated some of the DDAM support. If you ever do any work for the Navy, basically they've moved some of the analysis inputs into actual Femap, I believe. And then they've also added some new entries that you can define within Femap rather than in an external control file. And then if you have ever used tension-only quadrilateral shell elements in Nastran, you can now specify those in Femap to be written out to Nastran. And then this is kind of a big one. The Femap team has basically added the ability to add non-structural mass offsets, and they've kind of moved some of this around, so it may look a little different, but it's all collected down in this non-structural mass property values. I think previously there was not even an offset option because it probably just took these values, but they're separate now for the neutral axis offset. And finally, obviously for the kinematic joints and flexible sliders, they've added all that capability to the API. And there are a few new API entities or methods that may be useful, including they've also updated the check coincident nodes option. So if you are interested, there's a more complete list in their what's new documentation, and I would recommend reading through that because I haven't covered everything, and I've kind of trimmed this down to make it into like a webinar compatible format. But I think that's it. If you have any questions, don't hesitate to reach out to me or Keith, our Director of Sales. Thank you guys so much for attending, and we will be back again soon with more webinars and more what's new. So thanks.